Hello and welcome to Mr. Tompkins Ed Tech. This series of videos is based on the advanced information released by the exam boards ready for the 2022 GCSE exam papers. This advanced information gives detailed information about what will be appearing on each of the 3 papers and will help you focus your revision on the topics that will definitely be coming up. It requires a bit of interpretation and knowledge of the syllabus, so in these videos I'll be summarising this information for you, telling you exactly what topics you need to be revising for each paper. I'll also be drawing on my experience of previous papers to give you my best guess for the type of questions you might expect. I think it will be well worth your time watching it all the way through. If you're not yet subscribed, why not do that now and hit the bell so you'll be notified when these and other resources are uploaded. Now if you find this video helpful, please do give it a like. This really helps me out. Also, why not share the video with your teacher and your friends, as I'm sure they will also find it useful. Let's get into it. Just a reminder of how to use this video. Watch the video through first. I'm going to go run through every topic that's going to come up on the paper. Once I've done that, below the video you'll find a whole bunch of links to example questions matching up with those topics. So these are my best guess of the type of question that is going to come up. Very worthwhile going through each of those. Finally, I've included quite a big playlist of topics that I've identified with lots of extra questions. These to give you a bit more extra practice of those topics. So if you're struggling on a particular one, then definitely worth jumping through that and reviewing that material. Okay, so let's get cracking on this then. So the advanced information is broken down into the 6 mathematical strands: number, ratio, algebra, geometry, probability and statistics. And I'm going to go through each one and identify the topics and talk a little bit about them. Let's kick off with the number strand, and the first topics mentioned are highest common factor and lowest common multiple. Now you no doubt know how to find these two things exhaustively by listing all the factors of 2 numbers or all the multiples until you find one that's in common. But there is another method of using prime factor decomposition to find HCFs and LCMs, which I do recommend that you learn. It can often save you a lot of time in a calculator paper, because you can express products as prime factors with just one click of a calculator button. Okay. Also, don't forget that HCF times LCM is equal to your 2 numbers multiplied together. You can often use that to find one if you already know the other one. Right, next, error interval. Now this also, bounds came up in paper 2. This is just listed as error interval and it's on both papers. So I'm thinking this one is probably just a very simple, here's a number that's been rounded off, tell me what the upper and lower bound is. Okay, I don't think it's going to be anything more than that. I think this would have been already tested more fully in paper 2. Order in decimals, so taking a list of decimals and putting them from highest to lowest. Got recurring decimals down here too, so it might be ranking recurring decimals actually. So again, you'll remember recurring decimals already occurred in paper 1, which would probably be a more thorough, converting between recurring decimal and fraction. I think this recurring decimals is just going to be, here's a list of decimal numbers of which some are recurring. Put them in order of size. Okay. Product rule for counting, I usually refer to this skill as selection. It's like the number of ways you can select a number of things from a pile of things. I've got a whole video on this if you find it tricky. I know some people do find it a little bit conceptually tricky at first, but actually the maths involved is very simple. You're just kind of multiplying a couple of numbers together. But yeah, it's working out what those numbers are is the tricky bit. If you do find it difficult, check out that video. I've got lots of examples of selection problems for you to watch. Moving on to ratio. Share into a ratio, so taking an amount and dividing it up between 2 or 3 or more people using a ratio. Average speed, so knowing your distance, speed, time triangle and being able to work out one from the other. Population density. Population density is equal to population divided by area. You don't have to remember that, it will be on the paper if you need to use it. There have been sporadic questions on population density appearing in the past. I found one, I've linked to it below so you can have a quick look at that. Percentage increase, I do recommend using multipliers for these sort of questions on calculator papers. Don't waste time using a non-calculator method for a calculator paper. If you've watched any of my videos before, you'll know that I use a kind of FOM, final original multiplier triangle, for these sorts of questions. I've got lots of examples of the methods that I use in the videos that are linked in the playlist. So If you struggle with percentages, have a look at those. And then compound interest, so a very specific type of percentage increase where you increase it over multiple times, don't you? Again, plenty of examples of compound interest questions in the videos attached in the playlist, so if that's something you need to look at, feel free. Moving on to the algebra strand, and the first topic is quadratic equations. Now, I think last time, this is cropped up in every paper, so and I think last time I linked to a one where you solved it by factorizing. This time I've linked to a solving by formula. I have no idea which order or which way they'll crop up over the papers, but you may well expect to solve by factorization and a formula at some point over the 3 papers. Okay. Simultaneous linear quadratic. Okay, so solving simultaneously one linear equation, one quadratic equation. So you can't solve these by elimination. You have to use substitution. So you rearrange the linear one and shove it in the quadratic one, and hopefully a quadratic formula pops out, which you can then go on and solve. Quite common. You'll find lots of examples in past papers. I've linked one below. Simplification. So taking an algebraic expression and collecting like terms, removing brackets. That sort of thing. Triple brackets. Okay, that's interesting. So here you have to kind of multiply out double brackets twice, don't you? So you pick a pair and then you multiply them out, and then you take what you've got from that and then you multiply it by the other bracket. Can be a little bit tricky keeping track of all your various terms, but if you as long as you write your algebra down, don't rush, you should be able to get through and pick up all the marks for a question like that. Factorization. So either factorizing from a single bracket. Don't forget, if it says factorize fully, there's more than one factor that needs to come out, and you'll lose marks if you don't find them all. And double bracket factorization, so factorizing a quadratic. You should know how to do those. Quadratic manipulation. Not quite exactly sure what they mean by that, but given that the next 2 topics on the list are graphs, roots, turning points, and quadratic graphs, I imagine it's one of those ones where you have to solve an equation graphically by adding or subtracting another linear equation from it, or something like that. Okay, so graphs, roots, and turning points. So knowing how to find the roots and turning point of a quadratic. Presumably this is going to be from a graph as well, because the next thing is quadratic graphs. So knowing how to plot them. Don't forget you've got that function on your calculator that can find all the table of values for you, so make use of that. As well as quadratic graphs, we've got exponential graphs listed here as well. So an exponential graph is where x is the power rather than the base. So something like y equals 2 to the power of x. That's an example of an exponential graph. They're very distinctive shape. They always go through 1 in the y-axis, and they're increasing, aren't they? So yeah, you get to know what they look like. You should be able to draw one of those for a given graph. Composite functions, so that's where you've got like f of x and g of x defined, and then the question asks you to go on to find fg of x. So you have to take one function and kind of substitute it inside the other one, and then kind of work it all out. There are lots of examples in the linked video that I've attached on functions, so if that's not your bag at the moment, go and watch that video. And then we've got a couple of topics on sequences. We've got arithmetic sequences and geometric sequences. Arithmetic sequences is just a posh way of talking about linear sequences, the sequences that are going up in common difference, so 3, 7, 11, and so on. Geometric sequences are the ones where you have a common ratio, so that you get the next term by multiplying the previous term by a number. So, you know, if you're multiplying through by 3, then the sequence might be 1, 3, 9, 27, and so on. I've got a couple of example questions down here. One which looks at these 2 things algebraically, which you might want to go and look through. Generally, it'll be finding the next term in the sequence, but sometimes it gives you something a little bit more interesting to do with these things. So check that first example out, because I think that's worth looking at before the exam. Nth term. I can't imagine you would be finding the nth term of a geometric sequence. I'd imagine it's going to be more likely to be the arithmetic or linear sequence, which you should know how to do. It's fairly straightforward. Moving on to the geometry strand. First up, we've got area stroke volume, compound shape, comma, cylinder. Now this could be 2 separate questions. It could be like an area question on compound shapes, so a shape made up of like rectangles and semicircles or something like that. Or what I'm thinking it might be is that it might be like the the net of a cylinder. To define the volume and surface area of a cylinder, so you need to redraw the cylinder as a net of two circles and a rectangle and work out their combined area. So that's a possibility. A cylinder is just a circular prism, isn't it? So it's just area of the cross section pi r squared times its height. Questions around that. Quadrilaterals. Do you know all the properties of the various quadrilaterals that you need to know about? So just listing them off, obviously rectangles and squares, but you've also got parallelograms and rhombuses, trapeziums, and kites that you need to know about. And they all have like rules about how their diagonals cross, and you know how the angles relate to each other. So you need to know all those and be able to recognize and talk about those properties. Circle theorems. Yeah, there's a bunch, 5 or 6 different circle theorems that you need to know. Usually with these, I don't usually worry about too much about the angle that they've asked me to find first off. I just look at the diagram and think, well, what can I find, and kind of work my way around it, and eventually I kind of get to the point where I've answered the question that they want me to answer. So that might be a tactic that you might want to try. Remember, a lot of these questions ask for reasoning, so it's not about just finding the angles. It's also about saying why you think the angles are correct. So you need to make mention of and refer to the various rules, like the angle at the center is twice the angle at the circumference. You know, those sort of little things that you need to be able to reel off and write in your answers to get your reason marks, as well as finding the angle. Trigonometry. So presumably trigonometry means trigonometry in a right angled triangle, so SOHCAHTOA. So you can find the angle or the side given other bits of information from it. And then we've got sine cosine rules, so that's finding angles in non-right angled triangles. Now I don't know which one it's going to be. It could be sine or cosine. It could be both, I suppose, but it's generally one or the other. The example I've linked to is the sine rule, but if you want more examples, then check out the video in the playlist. It's got both sine and cosine covered in lots of detail in that. Vector arithmetic. So presumably this is just using column vectors, so adding column vectors or subtracting column vectors or multiplying column vectors. Sometimes it's paired with diagrams, but on the AQA papers I've seen, it's mostly just been based on the column vectors, so you don't have to kind of draw the vector shape, you just have to kind of do the maths. Link to something like that, but there's also a vector video that you might want to have a look at as well. Bearings. Now some people have suggested this might come up as part of the trigonometry or sine cosine rule question. I've never actually seen it on an AQA paper though. I've seen it on some of the other boards, but in AQA, bearings at higher tier have mostly just been tested as a kind of standalone question, where they give you like 2 points and some of the angles, and you have to kind of use your knowledge of angles in parallel lines to kind of turn it around the other way. So they might give you the bearing of A to B, and you need to flip it around and find the bearing of B to A. It could be in the sine rule, cosine rule question, it could be in the trig question, but as I say, my experience of AQA papers tends to make me think it would be more likely to be a standalone question. Very short list for probability, only one thing on it, and that is independent events. If events are independent, it implies that there's at least 2 of them, isn't it? So 2 things happening, and you have to combine the probabilities in one way or another. I've linked to an example question. Yeah, take a look at that, see what you think. Moving on to statistics, and we've got two-way tables. Two-way tables are just a way of plonking information down where you've got 2 different strata that you're comparing and finding number for. Struggled actually to find an AQA example. I think in the end I linked to an OCR one, but you'll get the idea from that. Histograms. So yeah, that's where it's like one of those bar chart pluses, where it's actually the area of the bar that's important and not the height of the bar alone. So you need to know how to take data from a grouped frequency table and find frequency densities and plot them on a histogram graph. There are some follow-up questions sometimes where you need to then look at use the areas of the bars to work stuff out. So sometimes they give you the histogram and you have to kind of work backwards by finding the area of the bar. And sometimes they ask you some tricky questions where they divide the bars up. So have a look at the example. I've got one there that does that. Box plots. Now, I think the next 3 things are probably linked. So we've got box plots, we've got medians and quartiles, and we've got interquartile range. Okay, so I'm thinking all these things are just going to be on one question. So you can have a box plot. Either they give you the median and the quartiles and get you to draw the box plot, or they give you the box plot and you're expected to read off the median and quartiles out of it. And there's a question on interquartile range, so perhaps they give you the interquartile range and the lower quartile, you need to find the upper quartile, or they give you both quartiles and they ask you to find the interquartile range. So I think all of those three are just going to be one fairly simple, straightforward box plot question. I've linked to 3 separate box plots questions below for each one of these 3 things, so knock yourself out with those. Line of best fit and outlier. Again, I think these 2 things are linked. This is going to be some sort of scatter graph question, isn't it? Interestingly, they don't actually mention it's the word scatter graph, but a line of best fit does imply that you need to have scatter graph in order to find the line of best fit from. So you should just know how to draw a line of best fit. Just don't try and push it through the origin. It doesn't have to go there. Just find the best fit line with a similar amount of points on either side. Now an outlier, you should know, is a point that doesn't meet, like it doesn't looks like different from the others, so it might be well away from all your other points, or your other points might be hugging the line of best fit and you've got one weird one far away, and that will be the outlier. I've also seen questions about outliers used to identify which is the appropriate type of average to use. You might be given an example of some data and being asked to find which is the best average to use. And one of the things might be that there's an outlier, so it means that you don't really want to use the mean because the mean is massively influenced by the outlier. So there's an example question below anyway, you might want to check that one out. Okay, and that's it. So a quick zip through all the different topics. Don't forget to go through the questions below. That's a really important bit. Me yabbering on is one thing, but you actually seeing an example of the type of question I think is going to come up. That's going to be the valuable thing. If you discover a topic that you do need extra help on, don't forget to look through the playlist of topics that are coming up on this paper. So I've made a playlist for each paper. It's got all the topics on there that I think are going to come up. Just pick out the ones that you feel like you need to do extra practice on. Okay? Don't forget that the best revision for these exams is to go through all the past papers from previous years. The advanced information really doesn't change that. Here's a link to all the past paper walkthroughs I've done. There's a link below each video where you can download the paper. If you work through all of those before your final exams, there will be really few surprises for you on the day. Good luck and see you on the next video.